crashing. If we want to activate memory debugging on Cray systems, there are two things that needs to be done. First thing, in the makefile, you have to link the application with the dmalloc library provided by Allinea. This is not necessary on most systems, but on Cray systems, the preload is not available, so you have to do it manually, regardless of your application being compiled dynamically or statically. So once this is done in the makefile, you compile the application and you run it with Allinea DDT. Okay? So if I do this, so DDT is starting. Because this is a GPU code, we want to activate a few things. Okay. So the first thing is we want CUDA to be enabled, okay? But because this is a memory bug, we also want the memory debugging to be enabled. Once again, because we are on Cray systems, we want to make sure that there is no preload that is done. And now we can use or not use guard pages. So by modifying the memory debugging options, you will activate more features. For instance, when you allocate an array, you can ask Allinea DDT to allocate it to 0, for instance, or to some dummy values to make sure it will crash the program if you're trying to read something, or different checks that are available. You can also customize those checks and put yourself the check that you want by modifying the keywords in this list here. Everything is detailed in the documentation. So by choosing the basic memory debugging, we add the guard pages. Now we have memory debugging that is working both on the CPU side and the GPU side of this application. So when this is configured, we click on Submit. The code will start, and we'll be able to debug it. Okay. So now if we click on our code, if we click on Play, so the code runs. There is one process that stops at exit. We have another process that is doing a segmentation fault. So this is typically an error that has been raised by the memory debugging of Allinea DDT. And if we look where this is happening, it's happening on a line we wouldn't think is a problem, right? It's quite a small line, doesn't look very nasty or anything. But regardless, there is a segmentation fault here. So because of the memory debugging, we have been able to identify a problem, and now what we want to do is try to understand what's happening on this line. So there are a few things that are available. So we have an array called A0, that's fine. We have those weird underscores, and we have values, IGK. This underscore is a macro. Okay, so if you've read the headout, you see that this macro is defined in himeno.h. It's here, and it will calculate a value depending on all those parameters. Okay, so now what I invite you to do is to calculate what the value of this macro is in this particular context. Fortunately, there's no mechanism to do this automatically. We have to do it manually. So. Okay, here I am. Okay, well, so are you doing the same thing? Not the same thing?
Probably the same. Maybe something here is wrong?
This looks good to me. This doesn't look good to me.
Ah. I had without preloaded thing.
I think that there are plenty of problems with the cluster. You haven't even, did you click on play or not even?
I played.
You click on play. Where are we?
Oh, come on. If I uncheck it? Okay.
Yeah, I know. I've reported this already. I don't know.
And I will have the same thing again now.
Well,
So, yeah. Think about erasing it. Where it is for me.
I have no idea. For you as well? Well, it's
Yeah,
working
no.
for me.
Then it give another message. Do you want to wait? Do you want to...
Devices are busy or unavailable.
I think the system thing.
Oui, il peut pas avoir un fichier pour Apache.
Comment ça? Je sais pas. Je me suis jamais posé la question. Yeah, that's good.
Yeah, it's good.
Okay, so that was the problem.
Why did you specify it? Because, like, I mean, I specified it in processors. Yeah, like, processors.
I know.
Yes. It doesn't work.
Sorry.
But it should work
Yeah.
afterwards.
Lui, l'erreur message you get, donc,
Can you do that?
Yeah,
Yeah.
I understand. Like, both nodes are on the same. Yeah, both processes.
So, ouais, mais c'était pas c'est pas le même que lui du coup. Donc, lui il y avait encore autre chose. Ok. That's good. That's what we want. Okay. So. Okay,
Because
okay.
it wasn't going anywhere actually at all.
So.
That should
Yeah.
be fine.
No.
Oh, no. Yeah.
That must be removed. Yes. It's doing something. It's moving. It's alive. So now if you click on play. That way. What you want, so you have your crash.
ouais, donc le point H,
Il est pas dedans.
même si tu... Si tu fais un view, même si tu cherches la déclaration.
Ouais. Je me le note. Any luck?
That is some memory debugging.
Oh, so it's at a startup. So did you, let me check. So here, because those menus are not available, it means that the memory debugging is not turned on. So if you, in session, so, okay, so I'll just remove this space. So to activate the memory debugging on the GPU, you click here, and this activates it here as well. So on the Cray, you need to make sure this is not activated. You can add the guard pages as well. You should click on submit. Now it should be on. Okay. Is it working here? Kind of? That's fine. Cool. All good? Alright. So, did you find out the...
Yeah, by one.
Yeah.
In access, well, they are not clear whether they are using where it is, whether they are using MK max or MK max minus 1. So this one is defined as MK max minus 1, and obviously you cannot say an array going to MK max minus 1 and then access to smaller than MK because MK max, because then it will well have an off by 1 access, I guess.
Yeah, so now the question is what should be in there. I don't know how you should actually write it. Because it's what was the guy who wrote this? What did he want to do in the first place? And that's the...
Well, the easiest possible in such case is just
remove one.
Get the bigger value, and in you will allocate a few bytes of memory too much, but as memory is not that expensive anymore.
Yeah, that's true.
Won't matter.
Yeah. Yes.
Three-dimensional array.
Yes.
Well, yeah, just too big, and it will take its time. And also with visit,
Yes.
we'll have some. Okay, so you just pass like the three-dimensional data to visit,
Yeah.
and you can visualize with any.
So exactly like this, exactly like the way you've done here. So IGK, and yeah, it will work.
Well, this is going to take forever, probably.
Oh, did he do a warning about? Yeah.
Yeah, I ignored it when
So just for your information, there is a cap, a limitation on the bandwidth, and we do not allow Allinea DDT to take more than 20 kilobytes a second.
bytes.
Yeah. So because we do not want to have an impact on the Infiniment or whatever, so we can take very, very long time. But the purpose of this is really to use the filters. If you're working about those kind of arrays, you want to spot the the rogue values.
Yeah.
Oh, there we go.
But I don't know what happens because it's not three-dimensional. Just plain, like here you see like columns, rows, rows.
Yeah.
Can I close it?
I think you've killed it.
Oh.
Is it closed? Yeah.
I think with visit there is no such problem, right? Because it doesn't send the data anywhere. It just works in its local.
Yeah. It's true. So definitely. Well, the drawback with visit is that the memory consumption on each node is rather important because the visualization tool needs a lot of memory to actually do his stuff. But well, it depends. I mean,
Yeah,
usually it's what 300, 500 megabytes. So it's yeah. But is this your code?
no, this is your code.
Oh, okay. All right.
Well, not yours, of course.
Well, yeah. Okay. So you need a calculator because there is no easy way. The expression. Oh, it's in the Himelo.h. I don't know if you have your terminal somewhere. No. It's a code viewer. But as I said to the people who were sitting next to you or just behind you, this is requests that we've seen every single time. So, well, you know. Oops, I know, everyone is trying. So if you're looking for... What was it? There it is. This is it.
This one, okay.
Is it visit is patched? No. For sure? No. I think visit needs to be patched.
So yeah,
I never tried, but if you're interested, I will do it.
yeah, I mean, I can probably do it properly.
It's only the...
What you can do is you could the visit that is working, but copy somewhere else. You can put directly in the application. Is giving as an output some weird values. So if we have a look at the handout, it would be easier. I think that the output value is something like 300,000 whatever. There we go. So this is the value that it has. Now the question is, we are accessing an array A0 at this block. So the question is, what is the size of the array? So to determine the size of the array, we can check where the array is allocated. So basically, the value is called mem size. So this is where you can find it. So in the evaluation window, you have the mem size here that is available. What you can do is, for instance, add an expression and say, okay, now I would like to see how many blocks this represents. So you divide the mem size by the size of a float. and you have the exact size of the array, which is exactly the same number of what the macro is. Which means that this array is going from 0 to those 3 million minus 1. And we are accessing the +1 version, which is outside the array. So this is the reason why it is crashing. Now the question is, how should we write this macro? What should be the correct value? I don't know, because I didn't write the code. I don't know who wrote it. I don't know what you wanted to do, but there must be a -1 somewhere in this that will prevent the bug from happening. Mm-hmm. So it should be like that, recon. Okay. So maybe. So if we change this normally, then there should not be a bug. So for this kind of bugs, well, as you've seen, when you run it in production, most of the time they are not spotted. People just ignore them or don't see them. But by using a debugger such as Allinea DDT, it is good to always run preventive runs, you know, with memory debugging, trying to actually go for the bugs, even if you don't know if there is one, just to make sure that your code is well written and that you won't have any problem in the future if you migrate on a different system, if you use a different compiler, or if you change anything in the environment. Okay. So those two examples that you've seen, this one is a CUDA example. And as you can see, debugging a code running with GPUs or running without GPUs is exactly the same. No difference. So do not be scared to migrate on GPUs. Do you have any question? So if there are no more questions, then I suggest that we have finished. So if some of you want to stay, I'm happy to discuss with you about other products of Allinea, because now we've just discussed about DDT. I've seen that some of you were looking at the backup slides that I had made in my slide deck. So if you want to learn about the performance report, or if you want to learn about Allinea Map, which is a profiler, feel free to stay or to keep around, and we'll discuss. All right. Thank you.